super excited to be here. I got to tell you though, I am nursing some broken ribs from a home repair gone fail, totally. So I may be tagging out Lynn Rushmore sitting in the front row there. He's going to definitely step up here during the Q&A. I had planned on roaming around a little bit, because that's how I normally speak with an audience, but I'm probably going to stay put here. And as I was introduced, I'm going to talk about maximizing sustainable cooling tower water conservation. A little bit about me. I am a cooling tower water conservation educator, and my main focus is to introduce and educate interested individuals and companies about maximum sustainable cooling tower water conservation. And I promise that I'll tell you what that means here in a little bit, but a little bit more about Turlin Industries. Founded in 1996, so this technology is not new, although it is just now emerging. We're experts in cooling tower water conservation. Over 19 years of professional hands-on experience with both the government and the private sector. Now, our focus is on performance, and as a lot of others have referenced, efficiency, and then sustainability. Attaining goals through sound and proven practices. We're a respected manufacturer of tested and proven water-saving technologies, and we're members of organizations like Alliance for Water Efficiency. I sit on the local BOMA Sustainability Committee, and many other organizations geared towards water conservation. I am quite passionate about it personally. For those of you that don't necessarily know how a cooling tower works, I'm going to give you a brief overview. Cooling towers are used in process or for, as has been referenced here quite a lot, in cooling large buildings. The water from the heat source comes into the cooling tower through the top generally and disperses over the fill, and it starts to cool. And there's large fans that will also kick on that help in aiding the evaporation of the water. And as that water is cooled more, it goes back to the heat source, and that's the basic way that it operates. There are some other things that happen inside the cooling tower. The water that's in the basin, when it's first filled up, has elements in the water that create hardness. And as that water is evaporated, pure water is what's evaporating. And that's good, because that returns back to the environment as rainwater. What's left behind are, the hardness, the elements in the water. And in order to replenish the water that's evaporated, more water is brought in through makeup to make up for the water that was lost through evaporation. But that also contains more elements that adds to the hardness of the water. And eventually, that water has to be removed from the system in order to maintain complete system integrity, okay? So that's a brief overview of how the cooling tower works and some of the things that we will be talking about in just a moment. So what is maximum sustainable cooling tower water conservation? In cooling towers, it's the ability to conserve the greatest amount of water while maintaining complete system integrity indefinitely. But first, must control scale, minimize corrosion, and eliminate biological fouling under all operating conditions. And that's generally done with a scale inhibitor, a corrosion inhibitor, and a biocide. And it's basically the same for any chemical treatment on cooling towers. So the performance and efficiency, sustainability also requires a comprehensive maintenance program to ensure that the equipment is being properly maintained and is in good operating condition and is performing at its peak efficiency as designed. Now, chemical water treatment programs are the most widely used means of protecting cooling tower systems. And of all the treatment products available for cooling towers, it's the scale inhibitor alone that determines the level of sustainable water conservation. Conventional scale inhibitors raise the saturation point of the condenser water to some degree. And although the elements, allowing the elements to be held in solution. And although this does reduce the amount of wastewater that must be dumped from the system, the performance is limited. So I understand some of the frustration in the room about cooling towers. In order to control the elements in the water and eliminate scale, conventional treatment programs require an average of 30 to 50% wastewater discharge to dilute the system and maintain complete system integrity. So I think we all can agree that cooling towers waste an awful lot of water. And I'm sure some of you might be thinking, why are we still using cooling towers, as a solution? The reason is because they're quite efficient at reducing heat energy. And if we can use the existing equipment, which is quite expensive to get in the first place, it'd be quite expensive to properly replace, not only for the cost of the equipment, but the logistics involved. Most of them are placed on large buildings, and to get those removed, you got cranes, stopping traffic, a lot of things involved. So if we can use the existing equipment and reduce the amount of wastewater, then it's a viable solution. The emerging scale inhibitor technology that I'm going to present today and talk a little bit more about, the Turlin CWT3 scale inhibitor, is a hydrolytically stable, high-strength chemistry that systematically controls cationic ions in water through sequestration, threshold stabilization, and crystal modification. The extreme ionic potential of this chemistry creates a synergistic attraction, or bond, between the CWT3 and the scale-forming elements in the water. And I know that's a mouthful. I know what it means. Some of you might know what it means, but a lot of time I kind of scale this down. The scale inhibitor has an incredibly strong negative charge. So here it sits, and when it's introduced to the system water or cooling tower, the positively charged scale-forming elements are attracted to it, and a powerful bond is created. Because it's completely water-soluble, it holds the elements in solution until they are eventually discharged with the wastewater. Okay? The blue balls, let's consider that the scale inhibitor, okay, on both of them. The blue ball on the left and the green ball on the right. The yellow dots are the hardness in the water. So you can kind of look at this in two different ways, the analogy. The scale inhibitor is kind of like a magnet first, and it has to attract it. So traditional scale inhibitor is a lower grade magnet. The Turlin scale inhibitor, electromagnetic, so it has a much stronger attraction. And then once it gets a hold of it, it's sort of the difference between Elmer's glue and super glue. Super glue just tends to hold on to things a lot stronger than Elmer's glue did. So again, I try to explain this to a lot of folks that may not have the experience that you in the audience might have. The program systems submeter both the makeup and bleed off water lines using impulse water meters with feedback to the control. This allows the proper amount of treatment based on actual system demand and to accurately monitor water consumption and wastewater loss. Wall mount feed control panel, a lot of this should look familiar. It's pretty much the same equipment in any chemical setup for water treatment. Use a programmable microprocessor control system, precision priming, parasolid feed pumps, monitoring probes, check valve, injection ports, condenser water flow switch, and isolation valves to create a clean, easily field installable package. And then our control system is capable of off-site remote monitoring and adjustment of a variety of system variables. Real-time alarm warnings can be transmitted by email and text, and the system can also be configured to communicate with building automation systems. So, why is this now an emerging technology? Those of you in the audience that are here and have an emerging technology, it's kind of like how a lot of people will think that an artist, a music artist, comes right out of the blue and they've been working for a long time on things. Emerging technology can have that same feeling. This is not new, what I'm presenting, but it is just now really coming out into the forethought because of increased water prices, droughts, and people looking for solutions. And so I want to tell you a little story, quick story, about how this technology is emerging. Kind of started really just recently, 2009. Denver Water, very progressive water utility company, decided to sponsor a water conservation and cooling tower study. And they vetted out a lot of technology and whittled it down to 4 different technologies that they really wanted to have this study on. So they put them on the same building, so the units shared equal load. Units were on the same rooftop. This is actually an aerial view of the rooftop. You can see the cooling towers there in the different quadrants. We installed the same controls on each unit, and so the results came down to if the technologies that could maintain system integrity, and which one saved the most water. When the results started coming in, again, all the units were allowed to run for 1 year. That was the cooling season for them. They measured water consumption, 2 sets of corrosion coupons, and bacteria counts. Corrosion coupon test results came in, all of them within industry standards. One in the blue is the traditional chemical technology. The one in green is the one that we're talking about today, the emerging scale inhibitor. Bacteria counts came in, again, all within industry standards. RTU3 is the non-traditional chemical chemistry that we're talking about again today. And then it came down to, for Denver Water, because they were looking for something that would maintain complete system integrity, would provide the highest water conservation, was economical for them to implement. And the one in green, the improved chemical technology, gave them all three, all the things they were looking for. So I'm happy to say that 6 years and running, 2.1 million gallons of water. This is a small tower. It's under 1,000 tons, very low demand. It is in Denver, so cooling season's short, water costs are low. But Denver Water was quite pleased with it, and the technology is remaining on the building. During this same time, Obama had signed an executive order, 13514, that all government buildings needed to reduce their wastewater or their water by 26% by 2020. That's since been superseded by a new executive order. It's now 36% by 2025. And during this time, GSA, our government's landlord, was looking for solutions themselves on their campuses. And they caught wind of what Denver Water was doing with their case studies and decided to do their own tests. And presently, the technology that we're talking about today has been implemented and has been on that campus for 3 or 4 years, showing successful results. And soon, we'll be able to share that data with you as soon as the reports are released. Today, I'm going to show you a few case studies of some buildings in my neck of the woods in Florida, where water costs are high, the water quality is terrible, and the demand for cooling is very high. So you can get an idea of the contrast of the impact. This is Park Shore Plaza condominiums. It's a 30-story high-rise building. They have 2 cooling towers, 1,200 tons, and as you can see, water costs $14, 1,000 gallons. And the ROI, a lot of folks have been asking about that on the new technology. ROI on this application was 4 months. Because during the first 2 years, system water consumption and wastewater discharge was reduced by 54%, saving 4.3 million gallons of potable water for the community. Another case study for you, over 300 units. This is another condominium resort, over 300 units. 2 cooling towers, again, 1,200 tons of cooling. Cost of water almost $18 per 1,000 gallons. ROI of 3 months. In the first 2 years, the system water consumption and wastewater discharge reduced by 50%. 4.5 million gallons of potable water saved for the community. And then finally, Bayfront Tower Condominiums is a 868,000 square foot waterfront condominium, houses 250 residential units. They have 3 cooling towers, 900 plus tons of cooling. Water costs near $8 and $9 with an ROI of 6 months. And within that first 6 months, system water consumption and wastewater discharge was reduced by 50%, saving 2.1 million gallons of water for the community. Now I created this last slide so that you can get an idea of the impact of implementing maximum sustainable cooling tower water conservation program. Perhaps you have some locations in mind yourself. And while you take a look at that, I'm going to put some closing remarks. I made some notes for myself so I didn't get off point. So you guys can go ahead and take a look at that and definitely see, the most systems run around 3 cycles per concentration. And between 3 and 30 cycles of concentration, there are quite significant amount of savings. There are Hundreds of thousands of cooling towers that range from 2,000 to 10,000 to 20,000 tons and higher. They could most definitely benefit from raising cycles of concentration beyond 3 or even 6 cycles of concentration. This sometimes not possible with traditional chemical scale inhibitors because the need to bleed excessive amounts of water in order to maintain complete system integrity. But remember, there can be no conservation if it's at the detriment of the cooling tower system, equipment, and the operation, which, as we all know, can be very expensive. The emerging technology utilized in these case studies and what is being implemented on more and more cooling towers effectively and safely increases cycles of concentration to 30 cycles of concentration, while maintaining complete system integrity. This slide shows the impact this can have on just one 1,000-ton unit with water sewer costs of $10 per 1,000 gallons, with a typical ROI of less than 12 months. As you can see, there is significant savings in both water and money well beyond three cycles of concentration. In addition, we continue to receive reports from facility managers regarding the nexus between the water savings and energy savings at these buildings. We look forward to sharing that data with you in the near future as well. Just imagine the impact this program could have on areas like California and other regions around the United States facing severe drought. Implementing this tested and validated maximum sustainable cooling tower conservation program saves water, saves money, saves energy, saves maintenance time. I'm sure many of you are going to have some questions. I, however, am going to step down because I am in a little bit of pain right now, so I'm going to ask Lynn Rushmore, the Vice President of our company, to come up and answer some of the questions. And I really appreciate being here today and meeting. I hope I get a chance to meet more of you throughout today and tomorrow, and I thank you.